Okay, so our last presentation will be given by Tom Jenkins. It's Escaping the Sandbox, Making in its Future. Let's welcome Tom.
So hi, I'm Tom. And a usual critique of maker culture is something like the one Jathan Sadowski and Paul Manson published at Al Jazeera, which basically amounts to the accusation that it is a kind of cyber-libertarianism. So here's Sadowski and Mason. The maker movement is born out of and contributes to the individualistic mass-market society that has become dominant in our time. New technologies promise to create a class of high-tech entrepreneurs, all while allowing them to ignore or simply design their own way around the established political, economic, and legal system. That's okay, fine. This is a reasonable critique of maker culture, but it's also indistinguishable from a critique one can leverage at almost all of technology culture today. It seems to us that the cyber-libertarian ideology critique covers over a more mundane but possibly more fundamental issue. Namely, maker culture is functionally hermetic before it's politically hermetic. That is, before making implicitly assumes a cyber-libertarian agenda, it isolates itself from a broader application domains it draws inspiration from. Electrical engineering, home automation, and even ordinary software development, for example. As a metaphor, consider a sandbox. Sand is great in a sandbox, but it only has use and value within the borders of that sandbox. Within the sandbox, sand is a resource. Outside of it, sand is a nuisance. From the opposite perspective, sand on the lawn doesn't make the lawn a beach. It just kills the grass. Likewise, grass in the sandbox has no function other than as waste. What this means is that the inside and the outside are each bounded domains. The sandbox and the lawn represent two sides that are in conflict with each other. And you can see some of this at work in hardware devices like Arduino, Raspberry Pi, and other electronics platforms that are common to so-called making. Ian and I have been referring to these devices as tinkering platforms. For example, the Raspberry Pi, their founders see education as a primary goal. They describe their platform as a tiny, cheap computer for kids that's developed to counter a trend among novice computer science students that seem to have lost the traits of hobbyist programming in favor of little, if any, experience with the real material of computing. The rise of processing, wiring, and Arduino also came at the same time as the rise of courses and then programs of study in art, design, culture, and computation at universities around the world. These devices quickly found home in these programs and then began to bleed out into the world after students graduated and took these to other venues. Their primary success is not in facilitating a new and deep understanding of electronics, but in creating a new ecosystem of tinkering activities separate from both traditional electrical engineering and arts practices. As an example of another kind of tinkering system, the Little Bits platform has educational aspirations, but it's meant for play. The bits themselves are like building blocks that connect together to create interesting things, but are not especially well suited to solving real problems in the world. A more specific example is the Twine, a Wi-Fi operated sensor-based monitoring device. The idea is that you're supposed to put your Twine in the basement with a moisture sensor attached, and you can use a web-based tool to program it to send you a text message if your basement floods. It might be an optimal outcome of maker culture in that it seems to produce a finished product that could go on and be sold and used. On first blush, it might be a proper hybrid of the sand and the lawn, but it's not. The Twine's uses are semi-permanent, but it can't really operate according to those demands. The batteries drain rapidly for one, and the last thing you'd want to do is rifle through your crawl space every couple of weeks with AA batteries. Even worse, the Twine is expensive, up to several $100s with all the sensors, and as such, its use as a piece of sensor hardware is at odds with its role as a tinkering platform that one can use and reuse through web-based programming. Instead of becoming a disposable, ubiquitous computing tool, it becomes a novelty object that allows a user to participate in a particular discourse of electronics, startups, and technical novelty. The sandbox conflict makes these devices primarily private rhetorical experiences that end up having very little interest in the world outside of the domain of their creation and support. It's interesting to compare these computational examples of maker culture with other creative communities that haven't needed that term, like knitting or woodworking. In these cases, we find domains that facilitate and support such activities, like hardware stores and craft stores, as well as a clear understanding that this craft practice operates on the register of avocation and hobby, as well as on the register of usable output. In these cases, the sandbox is viewed as a transitional object. It involves working with the actual materials that the broader world traditionally uses to accomplish goals, ratcheting up abilities with such materials, and eventually graduating to different levels of professionalism. So Ian and I have been trying to apply the hardware store metaphor to electronics tinkering platforms like Twine. We've been focused on very low-cost, low-complexity hardware components. which have resulted in working prototypes that do things like the twine, but far more simply. This new approach to tinkering systems assumes that a minimal, flexible, and inexpensive platform can overcome obstacles around the price of broad experimentation and make permanent use in application-specific objects more viable. So that's all well and good, but what we want to do is eat our dog food and really be sure that we're playing on both sides of the sandbox. We've been working on trying to make our prototype devices behave more like how we imagine a twine would have to acknowledge both the sand and the lawn sides. We've been building out the experimental process on ourselves of really making a small-scale, inexpensive networking apparatus necessary to demonstrate the principle we're trying to illustrate. In some sense, Ian and I have been the perfect candidates to do this because we're not professional electrical engineers, which has given us an object lesson on the difference between taking only satisfaction in the creative practice, which is the sand, or taking satisfaction in the marketable end product of the lawn. So I'll give you a quick sense of what making has been like for us during this time. We started using the PIC 10F200, which is a very simple 6-pin part, which we built into a board that included a potentiometer to tune a digital input by adjusting sensor voltage. We moved on to the PIC 10F220, which added true analog sensing, which was nice, but we still didn't have any way to communicate beyond the immediately visible or audible output. We moved to the low-power PIC 12F1822, which has an SPI interface for connection to peripherals, including radio transceivers. But even though we had enough pins in the spec sheet, we didn't have enough to accomplish SPI communication and input because one of the 12F1822's pin is non-addressable. It's designed to be a digital reset for embedded systems and applications. Well, what about the PIC 16F505? It's a 14-pin dip part. That's too many that we really wanted to use for lowering package cost and complexity, so we shifted our attention to the PIC 12LF1840T48A, a small chip with an onboard radio transmitter. The transmitter operates at 433 megahertz, so we decided to build custom receivers that operate on that frequency. But it also meant we had to test against the radio transceiver we hope to use with a new base station that we've been working on, which necessitated the wiring and testing of a communications protocol compatible with the transmission methods of the PIC 12LF1840T48A. We also needed to design and attach a sufficient antenna to allow a tiny PIC 12LF1840T48A to reach desired transmission ranges. While we've been confused and frustrated, we've also felt like we've been making something with native materials the whole time. So when you realize that, this might be what the knitting or woodworking equivalent of electronics packing might be like. And what it makes you realize is that working with an Arduino is actually kind of like buying a sweater, cutting off the tags, and calling yourself a knitter, when you're really just a consumer of sweaters. But we're not after the sweater, we're after a yarn store, or for us, really a hardware store, where the device we make abdicates its centrality as an object of concern and attention, and becomes a facilitator for other kinds of activities and uses. So extrapolating from this, we see 3 end games for maker culture that can be phrased as configurations of this sandbox conflict. The first is that those inside the sandboxes continue servicing their own desires, in some cases producing industries around those desires, but not really altering the outside ecosystems or reference activities where the maker activity aspired or laid claim to. In this mode, making is a creative and expressive practice, but it's a practice unto itself. The second is that the previous reference activities are abandoned in favor of the sandbox maker activity. This is, I think, the kind of thing we've been seeing in current maker culture, in the way that making has been spilling over into areas previously defined as the lawn. And the third outcome, those inside these maker activities recognize that the activity itself risks self-reference unless the apparatus of the sandbox is abandoned, once it offers enough lessons to inform a broader set of activities. So you could look at these outcomes more abstractly, like this maybe. And it won't surprise you to hear that option 3 is the one that we find the most promising. It also probably seems incredibly retrograde or boring. It's interesting in that way too. Ultimately, it behaves like ordinary craft work or traditional engineering. In fact, this outcome might be incompatible with the very concept of a maker culture, because the very point of the maker culture is to reject the desirability of a return to the reference domain in favor of spawning new sandboxes. Put differently, maker culture might be incompatible with anything but its own self-propagation. Thanks.
All right, do we have any questions for Tom? Okay, excellent.
My name's Paul. I'm from Queen's University. Your image of the sweater and the Arduino, I thought that was very cute. I agree with that in many ways. And you also had a very cute way of showing your process of making your own device, which I can empathize with because I've been there, I've done exactly that. But I'm not exactly sure what your point there is, because if you're anything similar than me, and I think you are, I have a philosophy background. I discovered an Arduino. I was, reading Merleau-Ponty and then building things with electronics. I started out with an Arduino, and that gave me the skill sets to even conceptualize the process that you were doing. And I'm pretty sure that you also got into this because you found these devices. So I'm not sure what.
Exactly right. I mean, I think you're nailing it. Part of it for me has been that since I've had this kind of time exposed to electronics manufacture of my own handmade kind, I'm intentionally avoiding a word, this other kind of branding has kind of crept into the scene. And I think what we're talking about in this sort of space in particular is the kind of particular marketing around making as a term of art and as a term of, especially within academia, to refer to something that has kind of no real referent. So what does it mean to be making when you're not really claiming to be making anything? It's just kind of a gerund phrase that is sort of a constant process without outcome. Does that seem like an answer?
I think it may, but I need to think about it some more.
Sure.
Thank you.
Yeah, no, thank you.
Okay, so if there are no further questions, we're running a little bit over. Well, actually, no, we're perfectly on time. Wonderful. Let's thank Tom. And